In this video, we want to solve for a, given that 4 raised to power a times 4 raised to power a is equal to 80. To solve this problem, let us closely observe the expression on the left hand side. We have 4 to the power of a being multiplied by 4 to the power of a. They both look exactly the same, and because they are exactly the same, it means we have 4 raised to power a squared. If we open up this bracket, this gives us 4 raised to power 2a. But 4 itself can be broken into 2 raised to power 2, and then now raised to power 2a would give us 2 raised to power 4a. Now let us go to the expression on the right hand side, which is 80. If we look at 80, we can break this down into 2 times 40, which can also be broken down into 2 times 2 times 20, also broken down into 2 times 2 times 2 times 10, and then we can also say 2 times 2 times 2 times 2 times 5, meaning 80 is equal to 2 raised to power 4, which is 16, then times 5. And if we equate what we just arrived at, which is 2 raised to power 4 times 5, to what we got earlier, which is 2 raised to power 4a, to each other, we are going to have 2 raised to power 4a is equal to 2 raised to power 4 times 5. I'll go ahead and divide through by 2 raised to power 4, so that on the right hand side I'm only left with 5, meaning divided by 2 raised to power 4 is equal to 5. Now I am going to apply another law of indices, which says if I have a raised to power m divided by a raised to power n, I can express this as a raised to power m minus n. So what we have here becomes 2 raised to power 4a minus 4 is equal to 5. I'll rewrite that on the left hand side here. 2 raised to power 4a minus 4 is equal to 5. With this, I can now take the logarithm to base 10 of both sides. So this is 2 raised to power 4a minus 4 is equal to log to base 10 of 5. There is a law of logarithm we can apply at this point, which says if you have logarithm of m raised to power n to whatever base it is, becomes n log m to that base. So the power in question here is 4a minus 4, and we can transfer that to the back here. So we have 4a minus 4 into log 2 base 10 equal to log 5. You already know the next step here, which is to divide through by log 2. So that this takes care of this, and on the left hand side I'm left with 4a minus 4 is equal to log 5 divided by log 2. Before I go ahead and solve for a, I need to work on this log 5 divided by log 2. There is a law of logarithm that says if you have the logarithm of m to whatever base divided by the logarithm of n in the same base, you can express it as log m base n, because they have the same base in this division. Now for that reason, 4a minus 4 is now equal to log 5 base 2. And you already know how to solve for a from here. We will need to move this 4 to the right hand side. A is a negative 4, and on the right hand side it becomes positive, meaning 4a is equal to 4 plus log 5 base 2. Then we can divide through by 4, so that this takes care of this. This becomes 1, and then all of the equation becomes a equal to 1 plus 1 over 4 log 5 base 2. And this will be our final answer. In order to confirm that our solution is indeed correct, remember what the problem was. 4 raised to power a times 4 raised to power a is equal to 80, and our a is now this. It means we can now substitute a into 4 raised to power, so this will be 1 plus 1 over 4 log 5 base 2 times 4 raised to power 1 plus 1 over 4 log 5 base 2. This should give us 80. Separating these powers by law of indices, we have 4 raised to power 1 times 4 raised to power 1 over 4 log 5 base 2, then times 4 raised to power 1 times 4 raised to power 1 over 4 log 5 base 2. This should give us 80. 4 times 4, this 4 here, times this 4 here is 16. So I have 16, then times the expression here can be expressed as 4 raised to power log 5 raised to power 4, 1 over 4 rather, base 2. The same thing to the last expression. So this becomes 4 raised to power log 5 raised to power 1 over 4 base 2, and it should still give us 80. Okay. We'll need to carefully look at this expression here, and it becomes 2 raised to power 2, because 4 is 2 raised to power 2, so we have 2 raised to power 2 log 5 raised to power 1 over 4 base 2. And the same thing applies to this. So still working on this, if we take this power and bring it right here, this becomes 2 raised to power log 2 base 2 of 5 raised to power 2 over 4. And 2 divided by 4, 2 here is 1, 2 here is 2, leaving us with 2 raised to power log 5 raised to power 1 over 2 base 2. And the fact that the base here is exactly the same with the base here, by law of logarithm, the final answer to this problem is 5 raised to power 1 over 2. Meaning all of this here is 5 raised to power 1 over 2. The same thing applies to here, 5 raised to power 1 over 2. Therefore, what we are left with is 16 times 5 raised to power 1 over 2 times 5 raised to power 1 over 2. If we write that out, we have 16 times 5 raised to power 1 over 2 times 5 raised to power 1 over 2, and this should give us 80. This is 16 times 5 raised to power 1 over 2, because there are 2 of it multiplying each other. That's 5 raised to power 1 over 2 squared should give us 80. 1 over 2 times 2 is 1. We are left with 16 times 5 equal to 80. If you multiply these out, 16 times 5 is 80, meaning 80 left hand side is equal to the right hand side, meaning that our solution here is perfectly correct. Thank you so much for watching. Hit that like button and subscribe to my channel if you are yet to do so, and I'll see you in my next video.